decimal numbers. But in case of when we are using a computer, then the binary numbers are the numbers which are used for the mathematical manipulation of all your information or data. So after apart from the binary numbers, we have different types of codes which are used to represent different types of numbers in a computer. And the very first type of code which is used is the binary codes. And we have a different type of binary codes. So let us take what a code means. Then we'll move how to generate codes or how to convert codes between the binary and different numbers. Now, a bit by definition is a binary digit, and when used in conjunction with a binary code, it is better to think that it as denoting a binary quantity equals to 0 or 1. So what you study in the mathematics, that is a digit, and in case of binary we will say it is a bit. So a bit can have only two values, either 0 or 1. To represent a group of 2 raised to the power n distinct elements in a binary code require a minimum of n number of bits. So if I say that I have in case of hexadecimal, so I have to represent 16 combination ranging from 0 to 15. So with this relation 2 raised to the power n, so if I put the value n equals to 1, then it is 2. So we can represent only two combinations, 0 to 1. If n equals to 2, then it is 4. 2 raised to the power 2 is 4. Then we can represent 4 combinations. If n equals to 3, then 2 raised to the power 3 equals to 8. That means we can represent 8 combinations. That is in case of octal number, then octal number can be represented by 3 bits. Now in case of hexadecimal, if I put n equals to 4, then 2 raised to the power 4 equals to 16. That means I can represent 16 combination, and that is the case of hexadecimal. So we can say to represent a hexadecimal number, we require at least 4 bits. So if I have n number of bits, then there are 2 raised to the power n distinct combinations or n 2 raised to the power n distinct elements. So this is the relation between the combinations and the number of bits required to represent any number. This is because it is possible to arrange n bits in 2 raised to the power n distinct ways. Take an example. Suppose a group of 4 distinct quantities can be represented by a 2-bit code. Now with the same formula 2 raised to the power n, so we have total 4 combinations. Then 2 raised to the power n equals to 4. When we solve for the n, then it will comes to be 2. So with the 2-bit code we can represent 4 combinations, and these combinations are 0 0, 0 1, 1 0 and 1 1. These are the 4 unique combinations that can be formed with the help of 2 bits, and no further any combination is left which can be represented by 2 bits. Now a group of 8 elements require a 3-bit code with each element assigned to one and only one of the following. So if n we have 3 bits, and then we will have 8 combination, and these combination, as in case of the octal number, are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. So these are the only 8 unique combinations which can be represented by a 3-bit code. Now the very first the different type of binary codes. The very first code is binary coded decimal, and we know it with the synonyms as BCD codes. We'll discuss later on in detail how these codes are generated. Another is BCD 2421 code, access 3 code, 84 minus 2 minus 1 code, gray code, and the last one is ASCII character code. So ASCII character codes are your whatever is your keypad in the computer, that is represented by the ASCII character code, and in the when we expand this ASCII, it is American Standards Code for Interchange. So the all your keyboard is coded with this ASCII code. This is the only use of the ASCII code when we are using alphabets. We have enter, we have shift, we have page down, print screen, insert. So these all keys are given a particular ASCII code, and that is American Standard Code for Information Interchange. So we'll discuss one by one each of these codes. The represent the decimal number using binary number is done with the help of the BCD codes. So all decimal number are represented by binary numbers with the coded form, and these are called as BCD code. Now to represent we have decimal number from 0 to 9, and with the 3-bit we can represent only from 0 to 7. A BCD code requires 4-bit to represent 0 to 9 in the decimal system. A to F, as in case of hexadecimal, A, B, C, D, E, F, and these represents 10, 11, 12, 13, and 14 respectively. These are not used in case of the BCD codes. So we are using only 0 to 9. That's it. Now, for an example, suppose we have a decimal number 185, and we have to represent it using BCD code. So what we do, we write a 4-bit code for each of the decimal number. Suppose 1 is 0001, your 8 is 1000, 5 is represented by 0101. So this 85 in decimal is equals to 0001 1000 0100. Then now this is your the BCD code. So what you have to do, you have to just represent each bit or each decimal number by its 4-bit equivalent binary number, and when we combine these three codes, and this is collectively known as the BCD codes. Now the characteristics of the BCD code, a BCD number need more bits than its equivalent binary value. If we directly convert this 185 into the binary number, then what we have the process, we have to divide each time by 2 and put its coefficient in A0, A1, A2, A3 like this. In this case, it requires to represent 185 in BCD, it requires how much? 4 plus 4 plus 4, 12 bits. And it may be possible that 184 will be represented by 6 or 7 digits. So this is the drawback of the BCD code, that it requires more number of bits. Now BCD numbers are decimal number, not binary numbers. That should be clear in the mind, that BCD code is a decimal number. It is not a binary number. So again, if we are given this BCD number, we can convert back to the binary number, a decimal number, just making a pair of 4 and writing its equivalent binary number. Now here is the example of the BCD code. You may note down this because in the next some numericals we'll need these BCD codes. So 0 is represented by 0000. All BCD digit will be of 4 bits. That should be keep in mind. So 0 is 0000, 1 is 0001, 2 is 0010. These are nothing but the just binary equivalent represented in 4-bit combination. 3 is 0011, 4 is 0100, 5 is 0101, 6 is 0110, 7 is 0111, 8 is 1000, 9 is 1001. Now with the four, as we know that with the 4 digits or 4 bits, we have total 16 combination. So the combination for 10, 11, 12, 13, 14, 15, these are not used in BCD, and these are known as unused states. So whenever we have, suppose after 9, we have 10, and 10 is represented as 0, 0, 1, 0. 1, 0 is not a valid BCD. That should be kept in mind, crystal clear, that we have only 10 combinations in BCD ranging from 0 to 9. Now suppose let us do an example. All of you solve it step by step. Now represent the decimal number in BCD. We have a number 576. Solve it by yourself. Represent 5 as 0101. Okay. 7 will be 0111, and 6 will be 0110. So your number becomes 5 is 0101, 7 is 0111, and 6 is 0110. So we write in without any space directly, the 576 in BCD will be 0101, 0111, 0110, and that will be your BCD code. Fine? Are you getting it or not?
जी sir.
Okay, fine. Take another example. Now we have a decimal number 98701. 98701. So write down its binary equivalent. I'll show you the table. 9 is 1001. 8 is 1000. 7 is 0111. 0 is 0000. And just write this number. This will be your answer in the BCD. The 98701 will be equals to, without any space, you just have to write without any space. It is 1001 1000 0111 0000 0001, and when we combine this in a sequence, in a string of, then it will be converted into BCD code. So given any number, you can directly convert number into a decimal number into a BCD code. Now come the BCD addition. How to add two number? This question came in the last year with 5 number in the university examination. We have to add two numbers using the BCD addition. Now suppose we have to add 184 and 576 in BCD. When we add directly in the decimal, then the answer should be 760. Now let us consider the algorithm, how we are going to add these numbers. So now the first step will be to convert both decimal number into BCD code. So you all just convert 184 and 576 in BCD. It is like this. 1 is represented by 0001, 8 is 1000, 4 is 0101. Now again 5 is 0101, 7 is 0111, 6 is 0110. So all of you solve this question in your copy and just simply add what we are doing in the binary addition. as we are doing in the binary addition. So here will be 0 plus 0 will be 0. We'll start from the LSB. Now this whole number is a total number. We need not to put any space or anything. We can consider it a string. So here 0 plus 0 will be 0. 0 plus 1 will be 1. 1 plus 1 2. यानी कि 0 carry 1. 1 plus 0 plus 0 will be 1. So here it is 1, 1, 1, 1. Again 1 plus 1 is 0, carry 1, 1, 0. So here is your binary sum. Let's check your answer. If the sum is correct, then we will move to the next step. Correct, sum is okay?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay, fine. Now look into the sum. The first 4 bit 1010 that represents 10, and 1111 that represents 15, and both 10 and 15 are unused state, which is not binary, which is not BCD, because we have BCD from 0 to 9. So 10, 11, 12, 13, 14, 15 are the number which are not BCD. So what we do, we have this sum, and this correction is done where there is any unused state. So here are the three combinations are there: 1010, 1111, and 0110. So 0110 is nothing but 6. That is okay. That is a BCD. This is 15. 15 is not a BCD. This is 10. 10 is not a BCD. So what we do, whichever term is unused, we add 6 to that particular basic term. So if the binary sum is greater than 9, then add 6. So these two terms are greater than 9. So we have added 6, and 6 is represented by 0, 1, 1, 0. Again, this 15, we add 0, 1, 1, 0. If there is only one unused state, so whichever is unused, we will add 6. If there all three are unused state, then we have to add 6 into the all three. If there is no unused state, then the sum will be your BCD. So we start adding this 6 to the binary sum. Then again start 0 plus 0, 0. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. And 1 plus 1 is 0, carry 1. So in this case, you just add this, then the answer will be like this. Here we start. 0 plus 0 is 0. 1 plus 1 is 0, carries 1. 1 plus 1 is 0, carries 1. 1 plus 1 is 0, carries 1. Then again this 1 plus 1 is 0, carry 1. 1 plus 1 plus 1, 3. 3 sum is 1, carries 1. Again 1 plus 1 plus 1, 3. Sum is 1, carries 1. 1 plus 1 is 0, carry is 1. So carry is forwarded again. This 1 plus 0 is 1, then 1, then 0. So this 0, 1, 1 is 7. 0, 1, 0 is 6. 0, 0, 0, 0 is 0. So 6 plus 4 is 0. 8 plus 7 is 15, plus 1 carry 16, carry 1. 5 plus 1 plus 1 is 7. So this this final answer after adding 6 is your BCD sum. Are you getting it or not?
Yes, sir.
Yes, sir.
Okay, now so there are two processes. Either we if there is any unused state, so either we can add 6 or we can minus 10, but plus 6 is better because it can generate carry bit to next digit directly. So what we do when we are adding two numbers in BCD, we just first of all we have to convert these number into, then we just add just like a binary sum. Okay, then we check all the combinations. If there is any binary sum greater than 9, then we add 6. Otherwise, If there is no greater than 9, then binary sum is your BCD sum. Or you can just check with the help of direct decimal addition that if your answer is correct or not. So here is your decimal addition and here is your BCD addition. Both answers should be same or should be matched. Now let us take another example. So you all start doing in your copies that add 763 and 549 in BCD. So what you do, you all first convert these numbers or represent these numbers with the help of BCD. Convert these numbers. Seven six three is like 0 1 1 1. 6 is 0 1 1 0. 3 is 0 0 1 1. Is that correct? Then 549, convert 549 in BCD. 5 is 0 1 0 1. 4 is 0 1 0 0. 9 is 1 0 0 1. And add these numbers simply as a binary sum. Now add these numbers. Then we'll check the what is the value of the sum.